Hey, welcome back, everyone, to the Data Ideas Podcast. This is Dustin, and I'm joined for this episode by Paul Moxon, who is the SVP of Data Architecture and the Chief Evangelist at Denodo. Welcome, Paul.
Thanks, Dustin. Glad to be here. Looking forward to this.
Yeah, I'm looking forward to this discussion. Glad to have you. Appreciate you coming on. So, Paul, you want to tell us a little bit more about what you do as SVP and Chief Evangelist at Denodo?
Yes, my glorious title of Chief Evangelist. It always gets questions.
Yeah.
I was actually I was doing a conference in South Africa, and a lady who introduced me to do my presentation said I had the sexiest title she's ever heard. So there you are, Chief Evangelist.
That's hilarious.
So what do I do? I work a lot with our customers and also with our sales teams at Denodo. Evangelizing, talking about data virtualization as a technology and how data virtualization fits into various data architectures and how it can help people modernize their data architectures, build modern data architectures for advanced analytics, etc., and accelerate those types of initiatives.
Cool. Awesome. And you've had this, if folks take a look at you, some folks probably listening already know you, but you've had this storied career. And I'm curious, if we go back to the beginning of when you first started to get into data, what was it about data that drew you in and interested you in it?
Well, again, you mentioned if you look back, if you go to LinkedIn or something like that and look at my history, I've been working in the integration space for many, many years now. And this could be application integration and data integration. So it's not really how did I get involved in data, how did it draw me in? It's sort of always been there. Cool. It's just part of what I've been doing. I've worked on large projects with people like Saudi Aramco, AT&T Wireless, Thomson Reuters, etc. And all of those big projects, they could be all refinery refits, etc., have always had a data element to these projects. I did data modeling at Thomson Reuters, for example. So data's always been there. It's just been part of what I do.
Very cool. And so Denodo is a data virtualization company, and you're chief evangelist there. How did you become passionate about this topic of data virtualization specifically?
Well, this actually started when I joined Denodo. And in all honesty, I hope my CEO is listening now. I didn't really know about data virtualization until I joined Denodo. And this was way back in 2013. And at that stage, at that time, data virtualization wasn't particularly well known. It wasn't particularly well understood. And I started reading about Denodo. I'd heard about this company and learning about data virtualization. It was sort of like, wow, this stuff is really, really cool. It's really, really good.
Right.
And that's what sort of drew me in. Also, at the time, well, not at the time, previous to that, in the early 2000s, I'd been working with a company called Sonic Software and Enterprise Service Buses. This is part of the application integration side of it. And this was the very early stages of service-oriented architectures, and the concept of ESBs was just emerging. And at Sonic, we sort of evangelized and created this ESB market. And I had this very, very similar feeling about Denodo. It was the very early stages of data virtualization. And it was a chance to drive awareness, drive adoption and understanding of this, effectively evangelize, I suppose, this type of technology. So it was just, wow, this stuff's great.
Cool. Yeah, and I feel like you mentioned 2013 this was?
When I joined Denodo, yes.
Okay. Yeah, that's interesting because in 2012, I think, was my first introduction to some of the more, we'll say, like advanced analytics tools that were starting to enter the market or gain popularity. Tableau was an example. I was part of an implementation going on at the time. And I feel like that was kind of, there's many critical moments, in the history of data analytics, but it feels like that time period was kind of one of them. And I feel like, the infiltration of all these tools, the data visualization side of things and statistics and the front end, is kind of driving the demand, for tools like data virtualization solutions. Yeah,
absolutely. Yeah.
Yeah. Very cool. So, tell me about, so you've got this interesting title of chief evangelist at Denodo. What did the rise to that title look like? What was your what's one's path to getting to the chief evangelist role? What did that look like for you at your company?
Well, when I joined Denodo, I joined to create and head up their product management function. Again, it was a fairly nascent company, a fairly startup feel to it. It didn't really have a product management function.
Right.
So I joined to start that, but over time, I was working more and more with sales, more and more with customers, explaining what data virtualization was. And back in those days, 2013, we had to explain it wasn't a replacement for ETL and things like that. And I did more and more of that. Well, eventually I evolved into that role. It wasn't such a career path as sort of evolving into this type of role of evangelizing, explaining the technology and how to use it. I wouldn't say there was a career path to be a chief evangelist.
Right. Yeah. And I mean, I like what you said earlier that, kind of data has just been part of what you do. It's just been this natural fit in some of the projects that you've been a part of, critical piece, in projects you've worked on. And it's, I'm sure something you discovered that is intuitive to you and that you're good at. And, you and I think some others that are in these evangelist positions that have emerged at companies have just kind of naturally progressed into it. But I think that's cool. I mean, do you think that we're going to see more evangelist positions like out there in the data space?
I think we do have them, and I think they'll grow because we're seeing the emerging technologies.
Right.
I'm sure within organizations, not necessarily vendors, software vendors, products companies like Denodo, but even within large organizations, you have the roles like a chief data officer, chief data and analytics officer. I think these are somewhat evangelist roles.
Right.
I know they have organizational management roles as well,
Yeah.
but really I always think of the CDAO or even a chief scientist is the person who goes and explains how advanced analytics, machine learning, etc., can help the organization, how they should use it. So they're really evangelizing some of the modern analytics that sort of are emerging and being used within organizations.
Right.
Because without that, and this is the scary thing about modern analytics, is it's overhyped.
Mm-hmm.
And people think it's magic. And unless you have somebody to explain what it can do and also what it can't do,
mm-hmm.
People have unrealistic expectations.
Mm-hmm.
And the scary part to me is I always think back to big data. And the hype moment for big data was when you had CEOs on earnings calls talking about how they were becoming a big data company.
Mm-hmm.
Okay, they've lost it. They've overhyped it so much it's going to fail. Now you have CEOs on earnings calls saying, we're going to be a data-driven company. We're undergoing data transformation and analytics is going to do it for us. And I think, oh God, I would hate to be the CDO in that company because
Sure.
the expectations are now just unrealistic.
Sure.
So I think you do need a CDAO, a CDO, a chief scientist, whatever it is, to keep organizations grounded about what's real and what's not real. And I see that in that case as that evangelist role.
For sure. Yeah, you make some great points there. And I think, evangelism, for any company that's actually gone through, the first several stages of analytics maturity, I think that at some point they've had someone, whether it's a formal or informal role, act as an evangelist internally, for the company. And it's a critical piece because you've got two sides of it, right? Like you could have an executive team that has these overinflated expectations because they're just hearing things from others that maybe aren't the best sources, or maybe they're reading things in the media, that don't really apply one-to-one to their situation, and they need someone to temper those expectations, but also get them, after they temper those expectations, re-excite them, but here's the things that we could do, and here's what that could look like when well implemented. And then on the other side of things, you have an executive team that maybe hasn't had a lot of exposure to some of these grandiose ideas of what analytics could do, and they just really need someone to be that catalyst to excite them about it. And so I think the evangelist role is needed internally, but then also, for companies like yourselves, I mean, sometimes you're not going to be working with a company probably that has an evangelist, and you have to come in and kind of help get them excited about it.
Exactly. You mentioned 2013 where you were talking about Tableau. I'm sure we may have called them champions or something like that. But somebody who really believed, look, this is not your father's BI. This is visualization and analytics. This is something different. And you have to have those people, whether they're called champions, whether they're called evangelists, whether they're internal or whether they're working with the software vendor. You need them to get people across into more modern technologies sometimes.
Yeah, for sure. I totally agree. And I've definitely seen the need for this in practice. So I'm glad there's more evangelist roles being kind of formalized out there.
It's fun. It's really fun.
Yeah.
It's
so
hard
you love
work,
it. You like
but
it.
I love it. I really do.
That's awesome.
I've got to say that because my CEO might be listening. But it's one of those situations where I actually think that I'm very lucky because I'm actually paid to do something that I really, really enjoy doing.
Right.
So
yes,
it's great.
Absolutely. Yeah. And I mean, I think you have to be, an evangelist, whether it's formal or informal in the analytics space, whether it's at a company or for, a company that serves other companies, through analytics and analytics tools. I mean, you really have to believe in it. If you don't believe in it, I don't think that you're gonna make it too long.
Yeah. Then you get core sales.
Right. Yeah. So let's switch a little bit to data virtualization specifically, because this is a topic that I've been learning about myself. I want to learn about more through this discussion with you, and I'm sure others that are going to be listening want to too, whether they're in the analytics space or in the business world, because it's really pertinent to non-technical and technical folks, right?
Yeah.
Yeah. And so let's start with the basics of kind of what is data virtualization and what does it look like when it's kind of well implemented at an organization?
Okay, so probably the easiest way of thinking about what data virtualization is think of it as a data access layer. You can call it an abstraction layer, a decoupling layer, whatever you want, but it sits between the data sources. And these can be your databases, your data warehouses, they can be file systems, they can be SaaS applications like Salesforce. It sits between those data sources and the users. So it decouples the users from the data sources. It allows developers, Denodo developers, platform, data virtualization developers to go and connect to those underlying data sources and define using drag and drop tools, how they want to integrate, combine, transform that data into something that's meaningful and useful to the user. Anybody who's used databases like SQL Server or Oracle, and they created views in a database, it's exactly the same concepts. It's just been abstracted out into this external layer, which allows you to build views across data coming from multiple different data sources. Now, to the user, the data access layer looks very similar to a database, albeit a virtual or logical database. They can connect to the data virtualization layer, this data access layer, using the existing tools, using standard protocols, standard formats, etc. And they can find and access the data that they need, the data that they're allowed to access. So now, as a developer, like say I'm building a dashboard in Tableau or Power BI, or I'm a data scientist who wants some data for my machine learning algorithm, I can connect this data access layer and get the data I need. I don't need to go and hunt for it and say, oh, I've got this stuff that's in Teradata, this stuff's been moved up to Snowflake, and this stuff's in a data lake. I just go to one place to get it. The data virtualization platform takes care of getting the data when you need it, on demand, effectively in real time, and delivering it back to you in the format that you want it, that's been defined.
Which this is a huge need, especially as the pressure to use data and analytics increases and the pressure to use data science increases. And I think as more data analysts and data scientists are hired on the front end of organizations, that it creates this natural demand for the data that needs to be used to produce something that's useful on the front end by these folks that are being hired into these data analytics and data science roles. And so huge need. You mentioned users of data virtualization, would a user typically be an analyst or data scientist, or is this still a data engineer that's a user of it, or what does the typical user look like?
It depends what aspect. If you're talking about consuming the data
Right.
from the data virtualization platform, it's typically a user.
Yep.
It could be a data analyst. It could be a data scientist. It could be something that we term power users. So people who are maybe not fully classified as a data analyst, but they know how to use tools so that they understand what a query is, so they can actually connect to the data virtualization platform from whatever tool they're using and run a query because they understand what a join is, even if they don't know
the basics.
As a matter of fact, what you can even do with modern data virtualization platforms is from an Excel spreadsheet, I can connect to the data virtualization platform and load data into my Excel spreadsheet. So now from Excel, I don't need to know anything about how to access a database or a data warehouse or a data lake. I can just connect and go and say, okay, I want to import that data. So I can get data from a Parquet file into an Excel spreadsheet.
Cool. And so what does a company that's, has a well-implemented data virtualization system in place, if they've got data analysts and data scientists, how does this ecosystem that they've got going on there compare to maybe that of a company where there's a more, traditional, so they haven't implemented data virtualization, but yet they're trying to hire analysts or perhaps do more with data? What are some of the differences between those two?
Okay. The main difference is that if you're not using a tool like data virtualization, you're using the traditional approaches. You've got to create some sort of centralized repository. It used to be, it may still be, an enterprise data warehouse. Very typically now, people are building data lakes, etc. And then you've got to go and build all the data pipelines to go and copy the data into that data lake or data warehouse. And my view is we've been trying to do this for the last 30 years. And we haven't really succeeded. Most organizations have multiple data warehouses. We've come across a UK government organization that actually has built 13 data lakes.
Oh, wow.
They were going to build the 14th to consolidate the first 13 when somebody said, hey guys, this is not going to work.
It's a big lake. It's like an ocean.
Exactly. So, the traditional approach is I'm going to copy the data in some sort of centralized repository. And if you want a new data set, you've got to wait for the data engineers to build that data pipeline, load it, maybe cleanse it or something like that before you can start using it. And a lot of organizations, they're saying that might be 6 weeks, it might be 3 months, maybe even longer. I did hear a Canadian company say 18 months, and that's the longest I've heard. But usually it's a couple of months before you get to the data. And that's too long. Whereas if you use data virtualization, really you're just connecting to where the data already lives. And that can be very, very quick. And if you've got people like data scientists who say, look, I just want the data. I want to be able to go and play with this data. I want to look at it, maybe run it through my algorithm or something like that. And actually, if it's no good, I want to throw it away. This is experimentation. Do you really want them waiting a month or two before they can do that? And then you build all these data pipelines and they say, nah, it's no good. There's no correlations. Ditch it. If you use data virtualization, you just connect into the data sources, building some very, very simple views, which will probably take you an hour to do that at the most. Then you say to the data scientist, try it out. If it works, we can then work with you to help refine it. But if it's not any good, let's stop now and throw it away before we go any further. So it simplifies and accelerates the whole thing.
Yeah, so simplification, speed to insight, accessibility, increases. These are some, just hearing you talk, these are some of the things that come to mind for me that would be benefits to a company that's wanting to do more with modern analytics. What is there anything else that a company that isn't leveraging, data virtualization would be missing out on if they're trying to jump and get into modern analytics without investing a lot on the, back end? What else might they be missing out on if there is anything?
One of the big things that you actually captured very succinctly.
Okay.
Actually,
unintentional, but I was just taking notes while you were talking.
So you sure you don't want to be an evangelist?
That
was actually that was very good. The one thing that I would add to that is future proofing and adaptability, and I'll explain this. So some of the things you've actually mentioned already is, the new technologies. We've talked a bit about this, that are being introduced. And if you think about it, there's been so much change in the era of data analytics that,
for sure.
If you think of the data ecosystem from 20 years ago, it's very, very different from what we're using today.
Right.
20 years ago, everybody was building data warehouses, and it was Teradata or Oracle, etc. Then 15 or so years ago, maybe less than that, along came big data and Hadoop, but everybody was started building data lakes on Hadoop. Everybody was going to be a big data company, etc. Now everybody's building data lakes on the cloud. They're moving up to AWS or Azure, and they're building data lakes up there. Now, in 5 years' time, 10 years' time, we'll be doing something else. I don't know what it is, but something else will come along and everyone will start doing it. There'll be a new thing that everybody wants to do. Now, if you've got data virtualization as this data access layer, this abstraction layer, again, decoupling the data storage from the users, then you can very easily accommodate change. So you can isolate the users from the changes that are occurring underneath that abstraction layer. So if you have a new data source or something like that, or we move away from data lakes into data ponds with a new technology or something like that, you can easily accommodate that. The users don't have to have radical change as you change the underlying architecture.
That's a really interesting point, and I hadn't thought about that. It's almost like you have these current benefits, but then you have potentially these future benefits from the flexibility that it offers. It's almost like a insurance policy. The flexibility is like an insurance policy against, the next 5 years potentially of future, let's say, tool enhancements or new tools coming into the marketplace or whatever.
Absolutely. Actually, just go back to, I'm going to throw this back to the scenario you talked about, where you talked about introducing Tableau. Mm-hmm. Probably before Tableau, people were using business objects. They were using MicroStrategy, maybe Oracle OBIE and things like that. Then along came Tableau, and everybody wanted to change. But, I built universes for business objects, or I've used the framework for MicroStrategy. I now go and have to recreate all that using data blending in Tableau or something like that. Mm-hmm. And then 5 years later, everybody wants to go to use Power BI. And all of a sudden, you have to go and build all that infrastructure again. Whereas if you do it in the data virtualization layer, you can just plug your tools into the data virtualization layer. And tomorrow, you can access the same data that you have in Tableau in Power BI. You don't need to do anything special.
Yeah, that's a really good point. That's interesting. And I think I see it all the time in terms of, new tools taking share, new tools getting more buzz. And, all of a sudden, the folks that are being hired are, all specialists on this new tool that came out. And then, does that mean that you have to now transfer all the reports you did in another tool to the newest one, And so I definitely can, I think you raised a really good point there. Makes a lot of sense. Let's talk a little bit about, if you don't mind, some use cases. And I understand you probably have to speak in general terms and want to be sensitive to, your customer base. But what are some of your favorite ways that you've seen data virtualization kind of being leveraged in the real world?
There are many, many different use cases. Building data marketplaces for self-service analytics, building next-gen data analytics on the cloud, and so on. But I think if I really think about it, my favorite use cases are the ones that actually change the business. the way the business works or the services it provides to its customers. So, and I can actually mention customer names because these are all public examples.
Okay.
So a few of my favorite ones. One is the National Health Service in Scotland. They provide primary and secondary healthcare to citizens in Scotland, about 5.5 million people. And they use data virtualization quite extensively. But one of the use cases they've got is what they call a cancer intelligence platform. Sorry, my headset.
Oh, no worries.
So the National Health Service in Scotland, one of the use cases they've got is what they call a cancer intelligence platform. And they use data virtualization to access data from 5 different cancer treatment centers in Scotland.
Okay.
And combine it. So now the cancer specialists, the cancer physicians can actually go and look up what was the most successful cancer treatment for this particular patient, for this particular demographic, etc. So now they're getting not just their own knowledge, but the knowledge from across the whole of the country, from these 5 different cancer centers, about how best to treat their patient. And that leads to better patient survival rates and things like that. So that type of use case is great to me.
That's awesome. That's a hard one to beat. Yeah,
it is. Another example, this is a manufacturing company. It's a German manufacturing company called Festo. And they've actually built what they call a green cockpit using Denodo. And this actually combines data from IoT sensors around their manufacturing plant, combined with information about their manufacturing schedules, etc. And it allows them to look at their energy usage on, heating, AC, etc., across the whole of their manufacturing plants, and optimize that energy usage. So it helps them with obviously cost control, but it helps them meeting their net zero commitments and things like that for ESG. So that's another good one because it's wider than, it's bigger than just the company.
Right.
It's the whole of this ESG initiatives that you get, especially in Europe.
Right, for sure. I love those examples because, I always like to tell people that, one of the reasons I'm in analytics is not just for, benefiting the current project or, organization that I'm, working with, but over time, there's really a true opportunity to kind of change the world with it. And, I think sometimes, folks believe me when I say that, and other times they kind of chuckle like that's a little bit corny. But I love the examples that you just gave because, that's world changing stuff. And that's what I think is cool about the field. And I think it's part of what is drawing folks into the field is that, how many points in human history or in how many industries were you able to actually come into something where you can actually change the world? You can actually improve healthcare. You can actually, improve environmental sustainability, and these are things that you can come in and do it rather quickly, right?
Absolutely.
Yeah.
Very true. I do go back to that thing about overhyping.
Yeah.
But and there's the example of, what was it? IBM Watson Healthcare, which got sold off because it was just not delivering. It had been overcommitted, overpromised. Right. But things like the cancer intelligence platform, the fact that as a doctor, I can work out the best treatment for my patients from the experience across the whole of the country is improving healthcare.
That's awesome. That's really cool. One thing that it's not necessarily data virtualization specific, but one thing I always like to ask folks that I do the podcast with is just what some of their favorite use cases are for modern analytics in general that you've seen. And I love asking you this question too, because of the amount of experience and exposure you've had to different organizations and use cases. And so what do you like that you see out there in terms of how analytics is being used? You obviously mentioned a couple examples, but
I'll give you 2 examples, which are not Denodo customers or anything like that. As a matter of fact, they nothing to do with data virtualization at all in many cases. One is, and this is actually my probably my favorite example of modern analytics being beneficial to everybody, is actually Google Translate. which is uses neural networks to do the translations. But it's incredibly powerful. And I'll give you an example. A year ago, the Denodo team in China got this Chinese government document. It was from the Chinese Academy for Information and Communications Technology. And it was a new document that was setting guidelines for data asset management. It was all in Chinese. And they said, Paul, we need you to give us some feedback on this document about how data virtualization can help in this. So they sent me this Chinese document. I ran it through Google Translate, and I could actually read it and understand it.
Wow.
There were a few things like data lineage became data bloodline, but it was completely understandable. And by the way, the Chinese version of data asset management is about 10 years behind where we are in the US, just out of interest. But it was just the fact that Google Translate gives you these capabilities, gives you the capabilities on the Android phones, for example, to speak in English and have it the speech translated into Spanish or Russian or something like that. So in terms of a consumer tool, translation, Google Translate is absolutely amazing. Another example, and this is prominent on my mind because I was actually speaking to a colleague's wife at this at a Christmas party recently, was the idea of smart buildings or even smart cities. So here you have systems that are running these buildings or even running the cities that are very heavily driven by analytics. And they can modify behavior based on changes in the environment. So it could be as simple as opening or closing window shades based on the sun shining and whether it's summer and you need to pump up the AC if you don't put the shades down, or even closing them to keep the heat in the building and stuff like that. Or changing traffic light, stoplight sequences based on traffic flow at rush hour and stuff like that. They're amazing examples of how we can get all this data, put it through some really smart analytics, and change the behavior of the systems dynamically.
I love those examples. And if we think about that last one with traffic lights and traffic flow, how would it be kind of in summary? You talked about how data virtualization works and some examples of how it's being used. But if we take that last example, what's a way that data virtualization could be used to accelerate that particular use case?
In the case of smart, actually we've been working with some organizations around smart cities and things like that. And smart cities is a good example because it means gathering so much data. And these data are in all different systems. It's not nicely put into a data lake or anything like that.
Yeah.
But just all the sensor information that you have in these smart cities to measure the traffic flows, the sequencing of the traffic lights are all in different systems and things like that. And it's even combined that with, okay, we've got special events. Let's go back to you, Dustin. You're going up to Green Bay. There's a Packers game. That's going to change the traffic flows from a Sunday when there's not a Packers
certainly
game.
Will. Yep.
So obviously, in a smart city, you change the traffic light sequences to improve the flow going to the game, and then in the late afternoon when the game's finished, it'd be to improve the flow away from Lambeau. So all those sorts of things. Now then, gathering all that data is going to be almost impossible to put it into a centralized repository because it's going to be owned by different departments in the city, maybe even different agencies owned by the state, never mind the city itself. So data virtualization allows you to access that data without trying to copy it all into one location. And we've seen this with government agencies, allowing them to access and share data with other government agencies without actually physically copying it, because government agencies don't like giving up their data. They like to keep it. So if you say, well, using data virtualization, you can allow somebody to access your data, but you still keep ownership and control of it, then they get more comfortable about sharing data.
That's a really interesting point. And I love the example. I think you just made some friends, some new friends from any of the Milwaukee area or Wisconsin area listeners with the Packers game example. That's cool. That's a great example. I love that. So what's as we wind down here, what's the best way that are there resources out there that you recommend to folks kind of on the topic of data virtualization if they want to learn more about it?
Yeah, I mean, obviously there's the Denodo website, Denodo.com.
Yeah, we'll put that in the show notes. Yep.
That's great. I mean, they can go there. There's information there about data virtualization, what it is. Another resource, there's a data virtualization blog. And this is literally the words data virtualization blog.com.
Okay.
And that's got blogs. It's not just the Denodo blog. There are blogs, posts in there from all sorts of analysts, from customers, from partners. So it's a great resource to find out about data virtualization. Sometimes, different use cases that a customer might write about how they've been using Denodo or data virtualization. So that's a great place to go as well.
Cool. All right, great. I'll put both of those, Denodo.com as well as the data virtualization blog.com.
Yeah.
Yep. I'll put those in the show notes. And if folks want to follow the work that you're doing, what's the best way for them to do that? Like, if they want to see Paul's next talk at a conference or something, what's the best way for them to know where you're going to be?
LinkedIn is a good place. And also the Denodo Twitter feed.
Okay.
They're always posting about my webinars, my talks, and stuff like that.
Cool. All right. So we'll link to your LinkedIn and the Denodo Twitter feed as well in the show notes. So if you're out listening to this podcast right now while you're driving or exercising or something, go ahead and take a look at the show notes, afterwards when you're back at your desk, because these will be some good things to take a look at if you want to learn more about this topic. Paul, anything that you want to share about data virtualization or its connection to modern analytics before we tune out here?
I think we've really covered most of it. I mean, one thing that I would say is that data virtualization, it's real and it works. I know that there's always skepticism when people hear about new technologies and stuff, but we've got some of the largest companies in the world from all industry sectors, JP Morgan, HSBC from banking, Caterpillar, Boeing and Intel from manufacturing, etc. So some largest companies in the world using data virtualization as part of their critical data architecture. So like I said, it's real, it works. And given the modern data architectures where you're going to have distributed data, it's going to be in different locations, it's going to be in different technologies, it's going to be in different formats. You're going to need a capability like data virtualization to build that next gen modern analytics platform that everybody's trying to build.
Mm-hmm. Awesome. Yeah, and I can certainly substantiate the fact that these challenges that you've talked about are very real, and access and speed to access of data, across a variety of places and platforms is very needed to fuel, the kind of the holy grail, or even sometimes in some cases the basics, from an analytics needs of an organization standpoint. So totally agree, and would encourage folks to read about this topic, take a look at the resources that we're going to drop in the show notes, and reach out to Paul, if you want to discuss the topic further. We'll link to his LinkedIn in the show notes. But thanks so much, Paul, for joining and having this conversation. I took a lot of notes.
No, thank you, Dustin. I really enjoyed it. It was fun.
Yep. Likewise. All right, cool. Everyone, we'll see you back next week, Thursday, for another new episode. All right. Take care now.